as the question says, a uniform rod of mass 300 grams and length 50 centimeters rotates at a uniform angular speed of 2 radian per second about an axis perpendicular to the rod through an end. Calculate the angular momentum of the rod about the axis of rotation, the speed of the center of the rod, and its kinetic energy. So here we are having a uniform rod which is suppose rotating about this end, this being the center. So let us proceed with the first part, in which we need to find out the angular momentum. As we all know that the angular momentum equals to I omega, where I is the moment of inertia while omega is the angular velocity. And we all know I of a uniform rod about one of its end, and omega they have given us in the question. So easily we can put that over here as equal to ml square by 3 into omega, and putting the values over here, where m is equals to 300 grams, L is 50 centimeters, omega is 2 radian per second, we get L equals to 0.05 kg meter square per second. Coming on to the next part, in which we need to find out the speed of the center of mass. We all know that the speed is equals to omega r, where omega is the radius. So here omega they have given us as 2. Radius is, because center is half, so it will be length by 2, giving us, it was centimeter, so it will give us 0.5 meter per second. Now coming on to the third part of this question, in which we need to find the kinetic energy of this rod. We know that the kinetic energy equals to half I omega square. You can look here that it is analogous to the linear kinetic energy. We have half mv square. So here moment of inertia in place of m and omega in place of v. Putting the values over here, we get half into 0.025 into 2 square, giving us 0.05 joules.